Okay, should we start? Let's start. So first of all, we all know about class, right? So uh, basically, a class is a logical entity. ठीक है? It is not a physical entity. So uh, you cannot call a class a physical entity. We'll understand it deeply. So a class basically has five things. Fields are also known as instance variables. I've talked about it. Methods that basically have some meaning to it, right? There are constructors. Constructors are nothing but a type of method, right? There are blocks. I don't know what blocks is. Yeah, so initialization blocks and static blocks. We'll also talk about it. Yeah, right. We'll talk about it. And a nested class and interface. So you don't know about interface yet, but nested class is basically a class inside another class. That is nested class. You have all heard about nested for loop, right? A for loop inside another for loop. That is nested for loop. So a class within another class is known as nested class. Is that clear? What is an object? An object is a real world entity that has state and behavior. This is very important. State and behavior, right? In other words, an object is a tangible thing that can be touched and feel like a car or chair, etc. The banking system is an example of an intangible object. Intangible meaning is basically you cannot touch it, right? Tangible is basically you can touch it, and intangible is not touchable, right? Every object has a distinct identity. Distinct is like unique, right? Which is usually implemented by a unique ID that the JVM uses internally for identification. JVM, you know about it, right? Yep. So there is pencil, apple, book, bag, board. These are the example of objects, right? So what are the characteristics of an object? There is a state, it represents the data of an object. Behavior, it represents the behavior of an object, such as deposit, withdraw. What are this? These are just methods, isn't it? This is state is basically the values, the instance variables or the static variables, right? It is not static variables because static variables belongs to the class. It is just talking about instance variables, right? Yeah, instance variables means the what is instance? Instance is just basically object, right? So any variables that you define inside a class is called instance variables until unless you write static before it. Whenever you write static before it, it gets converted into static variables. Locals are like specified within a block or method, right? So that are local variables that are uh, only scoped into that particular region. That is known as local variables. I've talked about it, I guess. Depends on the context. So if you are like defining a variable just below the class declaration, it automatically gets converted into a instance variable, right? After the public static void main, the okay. So if you're talking about the public static void main, then it is another thing. So if you're talking about declaring any variable here, right? This is local, right? This is local because what is this? This is a method, right? This is a static method. Yeah. So yeah, it is local variable. But if you just do the same thing here, then it is instance variable. Is it clear? This is just basically instance variables, and this is um yeah. So this is just local variable, right? Isn't it, are you clear? So there is and that is what I was going to make you understand. So we have declared same variables, right? Here it is a equals to 5 and here it is a equals to 5, right? Don't you think there should be a error in this program? Do you think? No, it there isn't an error because this uh, this local variables context is between this region, right? And day 5's context is this region. So if you are declaring another variable inside another method, then the context changes, then you won't be able to access this variable. Do you understand this? You won't be able to access this variable, right? So then you have to basically cheat through it. So you can do like this: a equals to 5. You know this is this. Got it? Yep. But there is a static variable, right? This method is static method, so you cannot call this. We'll study about it, don't worry. We haven't gotten into this keyword. We'll understand it. Are you clear with this one? So this mains context is this much. This main methods context is this much, but the day 5 classes context, this instance variables context is through all the class, right? So that is the reason there isn't any error here, because uh, whenever you create another variable with the same name, the context changes and you cannot access this particular variable. So if you try here, so let's say if you, yeah, it is bounded by this area only. So if you don't do this, if you just comment this line out, so this line is commented, right? So if I just do a out, right, and just print a and try to run the program, there will be some error. Why is non-static variable can only be referenced from a static context? Acha. Okay, so uh, just read the error. Did you get the error? So this is a normal instance variable, right? And we are trying to call this instance variable from a non-static method, from a static method, isn't it? This is static method, right? This whole thing is static method. Is it clear? So we cannot access a non-static method, a non-static variable. Non-static variable. This is a non-static variable, isn't it? It is instance variable that is equal to non-static variable, isn't it? So we are trying to access this non-static variable into this uh, static method, isn't it? Yeah, yeah, yeah. So we have to make this static. If we make this static, then it will be okay. Something is wrong here. Again, the same problem is, so see, so here it is telling that this name is non-static variable, right? We have to make this what? Static, right? Now we'll be able to do it. Yeah, right? Are we clear? I don't know why this program is running. We should run this program, right? Yeah, it is running fine. So this is static variable and we are trying to access the static variable from another static method, then it is okay. But as soon as we try to access a normal instance variable uh, from a static method, then there will be error, right? Are we clear with this one? Yeah. So we were just checking that this already instance variables that we have already initialized, can we access that from this method? We can, right? This I was just making you understand that this instance variables have this global context. So any part of that particular class can use that particular variable, right? But if we define another method, that is, let's say, uh, void display, right? And we have this int a, right? This int a we have, and if we try to use this, let's say another variable we create, share equals to 10, and if we try to print this share, you will see that it is giving us some error. What is this? Create local variable. It is telling that create a local variable. This is not shareable, right? This much context, this locals variables, the share variables context is between this method, right? It is inside this method. It cannot go outside of the method. Are we clear? Yeah. But if we want to display it, we can display it by another trick that we can do, that is basically passing here the share thing as a the variable as a parameter, right? We can share the parameter here, share parameter variables that will basically force this method to have another variable while you just call this particular method, right? While you are trying to call this particular method, you just share this share variable, right? Whenever you try to share this share variable, so again, this is, we have to make this static because we are just calling it, otherwise we have to create a object out of it, right? So now see, now if we are trying to share this variable, we'll be able to share it because we are just sharing this, right? We are just passing this as a parameter. So here we are passing this share parameter, that has some value. So this 10 is shared from here and it is received from here, and then we are finally printing it. Is it clear? Adrij, is it clear? Yeah. We'll also talk about it. We'll study about it very detailed, in a very detailed way. Yeah, we'll study about it. That is in the method section. When we'll talk about method, right? Then we'll try to understand what it is. Uh, See, the next section is methods. We'll talk about. Okay. Okay. So where was I? Yeah. So did you understand this part, that this is instance variables and this is local variable, and this local variable has has its context inside this method, and it cannot go outside the method until unless you do some trick. Is this clear? Yeah, very good. So we'll talk about another thing, that is behavior. We have talked about behavior. Behavior is basically methods that will study identity. An object's identity is typically implemented via a unique ID. The ID's value is not visible to the external user. However, it is internally used by the JVM to identify each object uniquely. Did you understand this part? So it is telling us that there is unique identity to every objects, and that is not publicly available to users or the programmers, right? It is used by the JVM to identify which object belongs to which class, right? or or the uniqueness of every objects. Are you getting it? The JVM uses some technique that by which it gives an unique ID to every objects, right? To just improve the performance. Are you getting it? So for example, a pen is an object. Its name is Reynolds. Its color is white, right? Known as its state. It is used to write, so writing is its behavior. So they are just creating a pen, right? That is an object, and it has its name as Reynolds, color is white, which is known as state. What was state? State are nothing but instance variables, right? So you can create a object dot name equals to Reynolds, object dot color is equal to white, and public void write, and you can just write system dot out dot print this pen is writing. You can't do that, right? An object is an instance of a class. What is instance? A part. Instance is just a part. The meaning of instance is part, right? So many of times you will hear the same thing used in the place of object. So whenever I will tell you that this is instance, you basically consider it to be as an object, right? There is two names to this part, so either you call it object or either you call it instance. That is the same thing. Got it? A class is a template or blueprint from which objects are created. So an object is the instance of a class. Got it? An object is a real world entity. Object is a runtime entity because it is created when the program is running. The object is an entity that has state and behavior. We have talked about it. The object is an instance of a class. Normal. This is how you create an object. Do you know how to create an object? Using the new keyword. So you give the class name, you give the variable name, assignment operator, new. You have to give the class name again, and first bracket open close, then semicolon. Yeah, we'll talk about the constructor. Don't worry. So what is the new keyword in Java? The new keyword is used to allocate memory at runtime. All objects get memory in the heap memory area. So do you know about the heap and the stack memory? Yeah, can you hear me? Yeah. Yeah, Audrey, do you know about the heap and stack memory? No, you know, don't know about it. So we'll have to study about it. So uh, the basic thing is that uh, let's say you declare a variable, right? You declare a variable int a equals to 5. So let's say we have, sorry, let's just make another thing. Let's say we create int a equals to 5, and we'll just copy it and just repeat this. We'll just change the names, B and this is C and this is D, and let's say we have 5. It doesn't matter, right? Let's say we have created some methods too. Right. Now whenever you write something in the program, right, don't you think this all variables, methods, and whenever you create objects also, right? So let's say you have a object that is named, you have a class that is named as calculator, and you are just creating an object. So let's say calculator obj equals to new calculator, right? And you have created this object, right? Can you understand this code? This is this is pretty easy, right? There is nothing into it. Can you understand this code? Yeah. This is a pretty easy code. We don't have to think much about it. This is, what is this? This is instance variables, isn't it? This is just instance variables. Instance variables. Or you can call it local variables. Let's just call it local variables or just variables, right? Or we have a good name to it, primitive variables. We talked about it, right? What are primitive variables, and what are the type of variables? We have talked about it. Methods. objects. Now whenever you define something, don't you think the all of these things need to be stored somewhere, right? Whenever you define something, I'm talking to you, Adrij. Whenever you define something in the program, don't you think all of these are stored somewhere in the computer? They are obviously stored somewhere, right? And you don't know about it. So we'll know about it where they are stored. So there are two things. There are two containers where mostly all of the things are stored, right? The first one's name is stack, right? The first one's name is stack. What is stack? How does it look like? So stack is also called LIFO. LIFO is basically last in, first out. What do you mean by it? What is this gibberish thing? I don't understand this. We'll talk about it. What is this? We'll obviously talk about it. First one is stack. One second. Yeah, stack follows LIFO, last in first out. We'll understand about it. Let me just write the second one. This is the first one, right? Stack. Another where all the things are stored is heap. These are the two things where most of the things are stored. And how to know which things are stored here, which things are stored here? To understand that, we have to understand what structure it follows. Heap doesn't follow any structure. Heap doesn't follow any structure, but stack follows structure. What do you mean by structure? This LIFO structure, last in first out. So the last element to be put in will be the first element to be taken out of that stack. What does it mean? Do you know about bucket? Let's visualize this as bucket. Do you understand bucket? So let's say you have a bucket, and you have some balls in it, right? So this is one ball, this is two ball, right? This is three ball. And now, can you do it? Can you pick this ball out of this stack without moving this and these two upper balls? Can you do that, Adrij? If you try to remove this ball from this stack, can you just simply do this? You cannot, right? You have to pick this ball out first. Yeah, you have to move this ball out, and then you have to move this ball out. So this is the structure that it follows. So let's say this is the last one to be put into this stack, right? This is the last item that we put into this stack. This will also be the first item that will be thrown out of the stack. Got it? That is why we called it LIFO, last in first out. Did you understand it? So this is how this is the first method. Basically there are two types of storage. This is the first storage in which we store primitive variables, right? These are the primitive variables like int, the small ones. So int, then double, right? Then we have long, float, all the variables that are primitive, considered into this primitive category. We store it into this stack. We talked about it, I think. Let's say, no, kind of, int a equals to 5, int b equals to a. What does it mean? What does it mean? B has the value of a, right? But do you think that if we change b, a will also get changed? It isn't like that, right? It isn't like that. So basically what happens is, in here in the stack, we don't store the reference to the variables. We just store the copy of variables, right? So the primitive types, whenever we create some types. So this 5 value will be copied to this b, right? This basically means this a will get converted into 5, isn't it? Isn't it? This a will get converted into 5, and then we will have this copy of a, that is 5. But do you think that if a changes in between, the b will also change? If it is like this, and let's say after some point of time we do this 10, do this 9, and try to print b, what should be the value of b? What should be the value of b, Adrij? A will change to 9, right? And b is pointing to a, and we are just printing this b. What will b store? B will not store 9. That is what I was trying to understand, to make you understand. So let's say there is let's say we have 5 here, right? We have 5 here, right? And what we did was, we were like, okay, there is some a, just write it, a which is pointing to 5, right? And after some time you told the program that okay, there is some b which will point to a, and the program will be like, oh, okay, we can do that. But what are the types? What are the variable type? They are primitive variables. They are int, right? The small int, int. So here the value is copied, the reference is not copied. What do you mean by reference? The thing that you told me that okay, if a will change, then b will also change, that is reference, right? That is reference. But here only the copy, the variables value will get copied here. So let's say if it is a, right, after the compilation is done, this a will change to 5. This b will have nothing, this b doesn't uh, care if a changes or not. Got it? It will be 5, exactly, because we haven't changed b, we have just copied the value. We have just copied the value which is stored inside a. That is why we told that program that okay, program, do a thing, firstly declare and initialize this a equals to 5, and then initialize b to a. And what is a? A is basically the value that is stored inside a, that is 5. So the 5 will be stored inside b. Got it? And if we change a, only a will get changed, b will not. Simple thing. Okay, so we were understanding stack, right? So let's just, there are many things that are stored inside the stack, but the main important thing that is stored inside the stack is, first of all, there is primitive variables. So let's say we have declared int a equals to 5, right? Let's just have this copy. Yeah, so this will basically, yeah, so this is how it will be stored. Got it? So this is how everything will get stored, but it will be reversed in order. So first int a equals to 5 will go there, and then int b equals to 5 will go there, int c will go there, and int d will go there, right? It will be in the reverse order. Just maintain that order, otherwise it is fine. So this is how it will look inside the stack. Got it? And you understand, right? Whenever you want to put anything outside the stack, you have to remove the topmost thing in the topmost from the stack, and then again then again then you can get the last element. That is why it is called last in. Whatever the element that is put inside the stack, which is the last item, will be also the first item that will be removed from the stack. That is why it is called last in first out. Got it? Yeah, very good. So what about the methods? Methods are also stored inside the stack. Got it? These methods, this in normal methods are also stored inside stack. Got it? So let's just copy this and let's just have this a little longer, and let's just let's just write 1-2 methods so that we can understand. First of all, we have display, right? So we have got display, and then we have calculate, and then we'll have add, right? So all of these particular things will be stored inside stack. Got it? The heap doesn't have any structure. The heap is like random position in the computer. So let's say this is heap. It doesn't have any structure like this stack, and it doesn't have any ordering also. Like the stack had last in first out order, right? Anything that will be stored inside heap will be stored like this. So there is an item here, there is an item here. So it doesn't matter. You want to remove something, just remove it. You want to put something in, just put it. If there is storage, put it. If there is yeah, heap, yeah, you can call it. It is the array also. I will make you understand. Actually, I'm not sure what you are meaning by two-dimensional array, but all of those arrays are stored inside heap. How? Yeah. I'll talk about it later, because that is a little advanced topic. You won't be able to understand all of this thing right now, but I will teach you all of that. So let's say, so there is one thing left. What are here? There is object, right? So that a dynamic memory allocation, whatever there is dynamic, all of these things are stored inside heap. Do you understand that? So whenever you use new keyword, right, all of the things are stored inside heap. So here you have used new keyword, isn't it? Calculator obj equals to new calculator. As soon as you create an object here, there will be a calculator object which will have this name obj inside this heap. Did you understand this? Where was the new keyword? This is the new keyword. The new keyword is used to allocate memory at runtime, right? Another difference is that this whole stack, okay, we'll just have some uh, Java, not Java, just stack versus heap. We'll have some uh, discussion about this so that we can understand what is this. We'll just talk about some. Yeah, memory is allocated in a contiguous blocks. Contiguous block is like one at a time, and all of those elements in the stack are one after another, right? So int D is neighbor of int C is neighbor of int B, and all of those things are connected. Heap doesn't have any connection, right? It is very random. You have another object, it will be here, another object. Got it? Allocation, automatic by compiler instructions. The manual by the programmer in C or C++, and garbage collector in Java or Python. This is very important. What do you mean by automatic and what do you mean by manual? So whenever you create something, add, calculate, display, how the things are like all of these things are storing inside this stack. You don't know about it, but basically you don't have that understanding how all of these things are stored. But in objects, you know for sure that whenever I will create some object, it is basically dynamic allocation, right? And all of those allocation happens because you are using the new keyword, and you know for sure that whenever I will use new keyword, it will have some specific storage inside this heap. That is what is told here. Got it? Okay. Stack has cost less, right? And heap has more. Got it? Stack has cost is basically the amount of storage needed for that particular thing. Yeah. Implementation, stack is much easier. Heap is memory fragmentation is there. I don't know about, you don't sorry, heap is implementation is hard because there is a little more complex. Whenever you have tight architecture, the whenever you know that okay, there is some architecture and there is some um, meaning to this whole structure, then then you will be able to design it well. But whenever there is randomness, this is randomness, right? There is no meaning into it. So whenever there is randomness, it becomes a little bit difficult. Got it? It basically becomes difficult to implement and manage. Okay, main issue is shortage of memory. So whenever you define a stack, right, most of the stacks have a limited memory. So it is like array. So you have to first tell the stack that okay, I need 10 memory. Got it? So how many memory are there? 1, 2, 3, 4, 5, 6, 7. So let's say here we have 7, right? And let's say you have told that stack that okay, there can be 10 memory. Okay, 7, 8, 9, and let's say we have one more 10. Got it? And this is like 10 memory, we cannot have more than that. So whenever this stack will be full in some time. Okay, but heap doesn't behave like that. Heap, you don't have to tell this heap when you create this heap that okay, be this this be this size only. Okay, the heap will automatically enlarge itself. So whenever there are more elements, it will try to fit those elements, but there is some limit in RAM. So after some times, whether be it stack or be it heap, it will basically overflow. All the elements won't be able to fit in this particular storage. But mainly you have to specify the stack size, and heap you don't need to specify the stack size, heap size. Got it? It is more like array. Stack is more like array. So whenever stack is implemented, right, I will show you how stack is implemented. Okay, I will write a program where a stack is implemented. There I will show you that inside this stack only we use array to store elements. Just we change the structure a little bit so that it behaves like a stack. Got it? In heap we generally use linked list and all of those things. We'll study about it. But the main thing is, like, when we define some array, we have to write the length of that particular array. Stack behaves the same way. Heap is a little bit different. Heap uses a complex memory structure. Is it clear? uh, we don't have to talk about it. Smaller than heap memory size, larger than stack memory. Got it? This is important. Preferred. Static memory allocation is preferred in an array. Heap memory is preferred in the linked list. We talked about linked list, right? I've just told you that linked list is used to implement the heap. We'll also talk about what is linked list. Yeah, what linked list is. I will write some programs on linked list. Don't worry. Yeah, it is another data structure that is used to store elements inside it, right? It is like array, but the structure is little bit different from array. uh, Whenever you define an array, you have to give the size of the array, right? That okay, this array will store 10 elements. It is not like it is not like that in Linked list can be huge. You can add elements and it will basically enlarge itself. There can be multiple like w- uh, mostly it can it will start increasing and it will only end when the RAM is full. Got it? When the memory is full. Okay. So yeah, we have just talked about stack and heap. Okay, are we clear with stack and heap? Did you get this? Yeah, good. It is pretty interesting, I guess, how all of these things are stored, right? This is the memory structure basically. Uh, I'll do a thing. I'll just try to uh, keep it a little bit separated so that you can understand later. Let's just name it two types of memory, right? I will I'll give you these notes, don't worry. I'll upload this on GitHub. You just can download it from there. Yeah, lol. So what this is the main class, right? What is the main class? Main class is nothing but this sorry, main class not it is just method, static method, right? So what is this main method? We'll talk about it. In Java, the main method can be declared in a class, which is typically done in demonstration of basic programs. Having the main method defined inside a class allows a program to run immediately without creating a separate class containing it. In this example, we have created a main class that has two data members, ID and name. We are creating the object of the main class by using the new keyword and printing the object's value. Nothing much, just the normal stuff you already know about it. Okay. In the real world development, it is usual practice to organize Java classes into distinct files and to place the main method outside of the class it is intended to execute from. This strategy improves the readability, maintainability, and reusability of the code. So it is said that whenever you write real world programs means whenever you go to a company and you write programs for their company, you write always you write another class and then you call that class inside this main class. You always create class main and then create this main method and then create objects of another class inside this class. Did you understand? This is what it is said. Okay. Initialization an object by reference variable, my method, my constructor. How can we initialize an object in Java? First of all, class student, int id, string name. This is one class. Another main class. Creating an instance of student class. This is instance. What is instance? Object. Yeah. Student s1 equals to new student. This is s1. What is s1? Object. Got it? Now they are assigning values inside this id. It's s1, this is s1, this is s1 dot id equals to 101. Now this will contain 101. Sorry, this will contain 101. Now this s1 dot name will contain sono. Now when you print this, it will get printed 101 sono. Normal stuff. Okay. Yeah. Also, Audrey was talking about something. Audrey said that whenever if we try to be if we where was that particular program that I wrote? Okay, I deleted that. So if we have something like int a equals to 5 and int b equals to a, and if we change this and print b, then it should also contain 8, right? This particular program should also contain 8, right? uh, this b should also contain 8, right? Adrish was saying that, and I told you that no, it is not the case because these are primitive variables. But this is the case for objects because objects doesn't have references. So this is not true. If we print this will be 5, isn't it? Because it will store b equals to 5. This is the case for primitive variables. Primitive variables. This will not be the same for objects. Yeah, non-primitive. What are non-primitives? Objects. Let's say we have a class uh, animal obj equals to, got it? Let's just write a program. We'll just, okay, first of all let's just create this object 2, and if we obj equals to obj2, we can do that, right? We don't have to initialize this, we can just declare it. And now if we change something in obj, obj dot name equals to let's say kurkure, right? And if we be like, okay, we'll just print obj2 and see whether the name is changed in that also. It will change. I will give you the yeah, just do this. I name it. Okay. Okay. So let's write this program. Let's do a thing. Let's just okay, this is looking not so good, so we'll just delete all of this stuff. Let's just comment this out. Yeah, what was the thing? Primitive, non-primitive reference. Got it? Let's just make a class animal and have private, no, we cannot name it private. Okay, yeah, let's just have a string name, and let's have int legs, int tail, and int eyes. Let's say these are the things, basic stuff. Did I name something wrong? Okay, there are two classes with the same name. We'll just name it animals. Yeah. So first of all, we'll create object. Let's have cat, right? Let's say cat1, new animals. This is the first, and let's just make it cat2 and cat1. Did you understand what I did here? I created one object that is named as cat1 and another object which has this cat1 inside cat2. Got it? Did you got it? Did you understand this? Yeah. Yeah, I'll repeat it, don't worry. Let me just give this values. Okay, is it clear, Adrij, what I did here? I just created a animal class and then created another object which is named as cat1, right? And just I have put some values inside this variables inside this cat1 object. So cat1 will now contain meow. It will have eyes 2, it will have tail 1, it will have legs 4. Let's just print it and check whether our program is running fine or not. Or let's just say cat1 dot name. Yes, eyes, tail, legs. Yeah, I've just made a class that has name, legs, tails, eyes. Created an object that has name, eyes, tail 1 and legs 4, and named it meow, right? And try to print it. We'll check it whether our program is running fine or not, and it is running fine. Where is this value printing? We'll just comment it out. Yeah, so meow 214, that is what it is printing, right? There is no problem in here. Okay, what we did is we had copied the reference of cat1 to cat2. So what we did was we gave this reference of cat1 to cat2, right? So cat2 has now the reference of cat1, not the value of cat1. Got it? Not just the value of meow 214, but the reference. The cat, whatever happens to cat1 will also happen to cat2. Now if we just print is out cat1 cat2 dot name, let's say, you know for sure that okay, it will also come meow. Yeah, no big deal, no big deal. But let's just try to change the value of cat1's name to meow meow, and let's just print the cat2 name. Try to understand what I'm doing here. I have changed the name of cat1 here, but I'm trying to print the cat2 name here. According to this concept here, we should be getting 5. We shouldn't be changing, we shouldn't be the value of the variables shouldn't change, but this is object here. Remember this. An object stores the reference. Yep, object stores the reference of the uh, object stores the reference, not the values. So whatever will change in cat1 will also change in cat2. So let's say, yeah, whole thing meow meow. This is this. We just printed cat2 dot name, and it is printing meow meow. Are we clear? And the reason why it happens is we have created cat, right? Yeah, let's just have cat dot name here. Let's say cat dot name is meow, or just have this value name equals to, let's say, meow, eyes equals to 2, let's say tail equals to 1, and legs equals to 4. This was the values that we had. We'll store them inside this thing. Now what actually happens is we have created two particular things. One is cat1 and one is cat2, isn't it? This both will point to this here. Did you understand now? Now whenever you change something here, the cat2 is also pointing towards here, right? The cat1 is pointing to here, cat2 is also pointing to here. Now you change this meow to, let's say, tatai. Cat1 will also have the name tatai, cat2 will also have the name tatai, isn't it? Isn't it? So this is how reference works, but it was not the same here. It was not the same here. it was quite different. It was quite different here. It here the value was just copied here. We didn't. Yeah, Adrij. Oh, okay. Okay, there's no problem. You can leave. Later, you can just watch it on YouTube. Okay, okay, yeah, yeah. Okay. So is it clear? Is it clear or no? Okay. Yeah. Where was I? Stack and heap. It is over, right? So meow meow is fine. We did this meow meow. Okay, we have a lot of things to understand. Okay. Object initialization through yeah, yeah, it stores elements inside it. All of the things that you create inside this program, they are all stored inside this stack and heap thing, and they are used by the program, the compiler. You don't have access to that. Got it? Yeah. Okay, this is another thing. So object initialization through method. Object initialization is basically whenever you try to initialize stuff through method. So let's say class student and int roll number string name, and you are not initializing these values here from here. You are not doing it from there. You are just creating some methods. Yeah. So void insert record, you are passing this parameter one int r, then passing this string n, and then you are copying this r to roll number, copying this n to name, and this will store this particular thing. Got it? So what it is doing, what this program is doing is basically he created s1, s2, and s1 dot insert record. He put 111 into this r thing, int r variable, and this current to this string n variable, and then n r is copied to roll number, n is copied to name, and finally they're printing this both thing. So this s2 will contain this 222 and rn, and then they're printing this. What is printing? Yeah. No, they're local variables. They are local variables. So whenever which one? Yeah, this roll number and name. It R and N, that are blocks code. It is it will only be accessible here. You cannot access outside of that. The reason you can access outside of that of this particular program is because you have copied that value into roll number and name, and roll number name is basically instance variables which has access to all of these things. But normally whenever you pass this int r and string in, it is local scope. You cannot use outside of this scope. Are you clear? Yeah. So lastly, you are just printing roll number and name. A roll number and name contains this r and n. As I've just said that this the only reason roll number and name can be printed because you have just copied this r and n here. Otherwise, you won't be able to print it. Got it? This is another way you can initialize an object. Object initialization. Object initialization is basically initialization of those instance variables in that object. So this is s1 is an object, and it has roll number and name. S2 is an object, it has a roll number and name, and it contains and it will basically be initialized using this insert record method. they get, they are like, exactly, they are transporters. They are just transporting values inside this whole object. Got it? You are doing this. You are doing this. Instead of that, you are just doing this. This is more simpler and smaller, and it is basically cleaner way to write things. S1 dot insert record. First of all, see how they have named the method, and it is so clear that, okay, oh, insert record, they are just inserting the records of the records of that particular student. So 111 is the roll number and Karan is the name. Simple. See, okay. Also, here the thing is very important. Stack memory and heap memory. So now what happens is, I told you about it, that cat1 and cat2 is storing this whole thing, right? Cat1 and cat2 is storing this whole thing, right? Now the actual representation of that whole thing is not so easy. So actually, this object this object will not be stored here. This object will be stored here because it is just a name. These variable names are stored here. Got it? And the values, the object's values will be stored here, the attributes. So like the instance variables will be stored here. So instance, got it? That is what it is told here. So S1 has some value that is here, given here. S2 has some value that is given here, and it is stored inside heap, and this is stored inside the stack. Got it? Now these are the bad ways of initialization. Got it? The actual way of initialization is a little bit different than that. How can we understand actual way of initialization? Object initialization through constructor. Actually, the initialization thing is on the main initialization of instance variables are done through constructor. Got it? Yeah. So how constructors are used? What is the structure of the constructor? Okay, that we need to understand. Yeah, we'll study about it. Don't worry. That is what it is told here, na. So what is constructor? Constructor is basically uh, the concept of object initialization through a constructor is essential to object-oriented programming in Java. Special methods inside a class called constructors are called when an object of the class is created within the new keyword. They initialize the state of objects by entering initial values. That is the same thing that I told. Where is the thing? Where is the thing? Where is the thing? Uh, yeah, there is constructor afterwards also. Don't worry. Don't need. We'll just study about constructor later after we have studied methods. So let's study about methods. We don't need. Okay. So what are methods? Methods provide us some behavior for this whole object, isn't it? So like writing, eating. Yeah, we have already learned about it. So whenever there is like anything, so methods name are always verbs, right? We have studied about it. That what are whenever we write some methods, we have to always keep the names as verbs. The naming convention tells us that only. So what are methods in Java? A method is a block of code or a collection of statements or a set of code group to perform a certain task or operation. This is important. So methods are basically something that performs a certain task or operation, right? It is basically used to achieve the reusability of code. What is reusability of code? Same thing, we don't have to write multiple times. Let's say, yeah, So let's say we have like animals, and let's say uh, we want to write that meow 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 is eating something. There is some issue there. Okay, so let's just say we want to write that cat, sorry, cat one dot name plus is eating, and we also have to write for cat 2, and let's say there are more uh, instance variables, instance more like cat, there is cat 3 and cat 4, also more objects basically, and for each of the class you have to write this thing, isn't it? So this is not reusability feature, this is basically code redundancy. Not really, these are just repeating codes, these are just repeating codes. You can do it better. How? Just have a method here, public void display or eating, sorry, and you can be like, okay, take the name, first of all, take the name and then write is eating, and you are done. How can you call it? You can be like, okay, cat 1 dot eating, done, 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 done. See, which is better? Writing the same amount of code multiple times is better, or this is better? This is one line here, but let's say let's say there is some complex logic here. You are just calculating some complex logic. Let's say there are like 100,000 lines of code, right? And for each object you have to write 100,000 of lines of code. For cat 1 you have to like cat 2, cat 3, cat 4, the same work you are writing 10,000 of times. That is just, yeah, that is very bad way of doing it, right? So the better way would be to just what, just have this method. Yeah, modularity method helps break down complex problem into smaller manageable pieces. This is self explanatory, you can understand by this only. Maintainability with methods, yeah, yeah, with methods updating debugging codes easier since changes in one part of the program do not necessarily impact other parts. So so a method basically uh, changes a part of the program, and most of the time you don't, changing one part of the program doesn't affect another until there is some interdependencies. That is another thing, but yeah, that is what it is said here. There is abstraction, we have talked about it, that hiding away complex details which is of no use for the user. Naming a method, what is naming a method? Oh, we have, yeah, this is just normal stuff, just we have already explained this one. This is how we declare a method. These are the types of things we also have. uh, this is already done, right? Let's just talk about constructors today, but before that we'll have some break. We'll have at least 10 minutes of break, then I'll come. uh, the 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 class will be long because we'll be going through many things today, right? First of all, wait a minute, where is that one that I just wrote? I wrote I wrote that what I'll do in this class. Okay, let's just have this break, and then we'll try to. So we have done revising the old stuff, right? We can start with the new stuff today. So we'll study about constructor, inheritance, polymorphism, abstraction, encapsulation, um, and no, not array. And we'll study something from here also. This is a book on Java. We'll study about the this keyword, the garbage collection, finalize, right? Then we'll also study about some specific parts from here, and we'll end the class. There is very much, there is a lot of things we need to talk about. Okay, I will just start the timer and I'll come after some time. Okay. Hello. Yeah, are you there? Good. We were doing constructor, right? Yeah. Yeah. Sorry. So what is a constructor here? A constructor in Java is a block of code like the method. It is called when an instance of the class is created. At the time of the calling constructor, memory for the object is allocated in the memory. Memory for the object is allocated in the memory. It is a special type of method which is used to initialize the object. Yes. Every time when we create an object by using the new keyword, it calls a default constructor. If there is no constructor available in the class, in such case Java compilers provides the default constructor by default. There are two types of constructors in Java: no arg constructor and parameterized constructor. Right? No argument, no argument constructor. That is called no arg. It is called constructor because it constructs the values at the time of object creation. It is not necessary to write a constructor for a class because Java compiler creates a default constructor if your class does not have any. This is very important. Okay, I'll make you understand this. Don't worry. Rules for creating Java constructor. Constructor name must be the same as its class name, right? Whatever the class name, you have to name the constructor's name as the same only. A constructor must have no explicit return type. Okay, you don't have to mention return type to the constructor. Once again, did we do methods? Yeah, we did methods. A Java constructor cannot be abstract, static, final, and synchronized. Yeah. So what is here? What is it told here? A Java constructor cannot be abstract, static, final, and synchronized. You cannot have all these keywords linked to a method, linked to a constructor. You cannot give static, final, synchronized, abstract. Got it? But we can use access specifier while declaring constructor. It controls the object creation. A constructor may be private, protected, public, or default. Got it? Sorry. Okay. What are the types of Java constructor? Default constructor. No arg constructor is also called default constructor. And there is parameterized constructor. Huh? Yes. What is default constructor? When a constructor does not have any parameter, this is known as default constructor. Got it? Examples of default constructor are, in this example, we are creating the no arg constructor in the bike class. It will be invoked at the time of object creation. So let's just do a thing. Let's just create a code here. Yes, let's just write a code. Let's just create another class here that is called class, let's say box, and we have int length, int breadth, yeah, and we create a default constructor, default constructor, public. It should have the same name as class, right? Box, since it is also a method, we should have parenthesis and we'll open the second bracket, right? And here we'll have to initialize. So we can be like length equals to 5, breadth equals to 10, basically a rectangle. Can we do this? Obviously we can. Let's just call this box. Let's just call this box default constructor box, creating objects of box. So box 1 equals to new box. We call this, and let's just check what the value of length and breadth is. We can be like method to display the box method box length breadth, public void display is out yeah is out length and breadth. Okay, here we'll be just calling this method box1 dot display. Did you understand this? We have created this box default constructor initializes the length and breadth here. Got it? And we are just calling this box here, and we are just displaying the box. We'll just check whether our program runs fine. Yes, it is running fine. We have got the 5 and 10. We'll just comment it out so that we can understand what is this. So we'll just add some lines here. The length of the box is there. What happened? Right. The breadth. Got it. So let's just test. Yeah, it is working fine, right? This is the default constructor. Got it? Or the knower constructor. Now, did you understand that whenever the object is created, this part of the code is automatically run? Though this is a method, like this method, it doesn't gets automatically called. This method we have to call it, right? But this method gets automatically called. Like, so that is the proof that this constructor was made like this, that whenever automatically called mane, let's say this is manual call box1 dot display, you are calling it, the programmer is calling it, right? But we are not calling this box method. Are we calling this box default constructor? Are we calling this? This is a method, right? But we aren't calling it. We are just making this object and just calling this display method. But still, see, this length is 5 and breadth is 10. How this is happening? We know for sure this default constructor is getting called. So let's just write just to check the default constructor is called. See, so the default constructor is called as soon as you create this object here. Got it? So what happens is, basically when you create this whole object, right, whenever you just mention that okay, new box, see this box, the signature of this box is actually the same signature of this, isn't it? This box constructor is basically this one, isn't it? Is it? So that is why you are just calling it from here only. Got it? So whenever you are creating an object, normally a default constructor is always called, whether you mention the default constructor explicitly or not, it doesn't matter, it will always call it, it will always get called. So if you have this box, right, if you don't have this box, you will still write this, right, you will still write this box, isn't it? if you don't if you don't mention this default constructor explicitly, you you will still write this new box to create box 1 object, isn't it? Yes. So that is that is why, uh, that is the proof that whenever you create a class and you create an object, if you don't mention a default constructor, the compiler will automatically generate a default constructor for you that will have some structure like this. This is the structure of the default constructor that will be generated by the compiler. This is generated by the compiler whenever user don't mention the constructor. Got it? What here, what I have written here is important. This is generated by the compiler whenever user don't mention the constructor. But if you mention the constructor, here, then it will not run. Then the program will treat this as the default constructor. Got it? Is it clear? Just mute your mic. There is some uh, yeah, sound. Did you understand this part? So first of all, if you don't create the constructor, so like for this for here, if we don't create this public box, then the compiler will generate this public box which has nothing in it, right, empty particular braces, and it will contain nothing. And this it is after the whole thing is created, this is basically treated as this box. Got it? So either you create constructor or not, it doesn't matter, a class will always have constructor. If you don't create it, the compiler will make one. If you create it, the compiler will not make one. Got it? There will only be uh, one default constructor. Got it? Other than that, you can have multiple parameterized constructor, but only one default constructor with no argument. Got it? Okay. See, if there is no constructor in a class, compiler automatically creates a default constructor. Got it? So there is a class bike and there is no constructor inside it, but the compiler will make bike open parenthesis open close. What is the purpose of default constructor? Provide the default values to the object like 0, null, etc. depending on the types. Got it? So the compiler will automatically write some code inside it. So let's say this length is int type, right? So int will store 0 here, breadth will store 0 here. The compiler will give some values if not mentioned like this. If you don't mention it, yeah, like the default values. So if we don't create it like this and try to print this, you will see the values is 0 and 0. So the compiler automatically initialize the values to 0. Got it? Yes. And if we don't do it, if we explicitly mention the values, then obviously we'll get 5 and 10, isn't it? See? Okay. Okay. Java parameterized constructor. Now this is very interesting. What is parameterized constructor here? The parameterized constructor is used to provide different values to distinct objects. However, you can provide the same values also. In this example, we have created the constructor of student class that have 2 parameters. Do you know what is parameters? I've already told about this in method. Yeah, do you know about parameters? Parameters. Method have some parameters, right? Yeah, can you hear me? What happened? Yeah, can you hear me now? Yeah. Good. So the thing I was telling you that, do you know the meaning of parameters, right? So in a method, if you uh, mm, like the elements that you are sending from your public static void main to the students methods, that are like the local variables that are used to copy the variables or just to send them to calculate something, that are known as the parameters, right? I've already talked about in the method class. See? Yeah. Parameters int a, int b, you know about it, right? Yeah. So what are parameterized constructor? Let's just study about it. So instead of doing this, like length equals to 5, breadth equals to 10, let's just make it 0 and 0, because that makes sense, more sense, because the default constructor doesn't know, we cannot hard code this, right? So if we hard code this, every object that we create will have 5 and 10 as its length and breadth, right? But that is not the case. We want multiple boxes which has different length and breadth, isn't it? So what we will do is we'll just comment it out for now and try to create a parameterized constructor, because uh, we can also keep it, and also be like, okay, let's create a parameterized constructor and public box int length, int breadth. So this is the parameter 1, this is the parameter 2, isn't it? Now whenever you have to call a method that has parameters, let's say there is a parameter wala method. So let's say public method to uh, take some value from the parameter pub, public void display here display parameter and int a and int b. Now whenever you have to call this method, you have to be like box 1 dot display parameter, and you have to pass the values, right? So like 10 and 20, and see, the a will have 10 here and b will be 20. Where is a and b? So will have 10 here, b will have 20 here, then a will get printed, b will get printed. Let's just print and check whether it is running fine or not. Yes, it is running fine, right? So you will have to pass the 10 and 20, otherwise it will not run. So if we try to run like this, will it work? No. See, it is giving us expected 2 arguments but 0 found, because here you have mentioned that whenever it will work on the basis of int a equals to 10 and int b equals to 20. You have to give some value inside it, otherwise it won't work, right? So this will only work when this is the case. Okay, so that is done. Another thing what we were learning, yeah, so what is parameterized constructor? It is basically getting, you have to pass some values inside it, and otherwise it won't work. So let's just say you create another box that is named as box 2 and you create this thing. Now for this the default constructor will get called, isn't it? For this the default constructor will get called, isn't it? What is the default constructor? This is the default constructor, because the signature matches, this is the same as this, right? But if you want to call the parameterized constructor, what is parameterized constructor? This one, you have to pass length and breadth here. So let's just try to understand that. Let's just make it L and R, right? Sorry, R is like breadth B, right? And be like length equals to L, breadth equals to B. What is length and B? This is length, this is length, and breadth is this. Okay, but we have to pass the values. So let's say we put the length as 20 and breadth as 50, right? And let's try to display what sorry, display is just not normally display. Let's just first write it that whether the parameterized constructor is called or not. So let's just put it here that the parameterized constructor is called, right? Let's just run the program and see, the parameterized constructor is called, the length of the box is 20, the breadth of the box is 50. Are we clear? Did you understand this? So the signature matches here. Parameterized constructor so basically the signature matches. How the signature matches? Parameterized constructor, public box, you wrote int L and int B as the parameters. So you have 2 parameters here and you are giving 2 arguments here. So both of those are checked, and when they are matched, the new box, the parameterized constructor gets called and another object is created. Note that when the object is created, this default constructor is not called, because you have called this constructor, and at a time when there is an object that is created, only one constructor can be called. Got it? Did you understand the constructor thing? It is basically very easy thing. Constructor is a special type of method that is called automatically when an object is created, and it is the first method to get called. Second, it is used, the main objective of that constructor is to initialize instance variables of that object. Is it clear? Yes. Now we have to study about constructor overloading or method overloading first. Do you know about method overloading? Do you know about method overloading? Yeah, this is very uh, interesting thing. So sorry, don't have to write so many things. First of all, let's just create a calculator class, right? And we'll create int a, int b, int c, and d. Got it? Now, Tatai, tell me one thing. Tell me one thing. Uh, let's say our calculator only does addition now. Got it? And the main thing is we want to write a program where it can either add one number, add two numbers, add three numbers, or add four numbers. Got it? Now, let's say we design some methods, but at first we have to create constructor, right? Let's just make parameterized constructor. Is it okay? Yes, we can make a parameterized constructor calculator. So we already have some calculator. So let's just calculator add, and we have to name it calculator add. And first of all, int, let's just create this. Okay, let's just name this var1, var2, var3, and var4. And we can be like int a, int b, int c, and int d. And var1 will store a, var2 will store b, var3 will store c, var4 will store d. Tata, this is so much confusing, isn't it? This is so much confusing. Var1 is a, var2 is b. Shouldn't we do something like, can we do something like this, that var1, var2, var3, var4? And if we do something like this, var1 equals to var1, var2 equals to var2, var3 equals to var3, shouldn't be it easy to understand? Then okay, obviously var1 will get into var1, var2 is equal to var2, var3 is var4, but there is some error here, right? Same variable names, there is no var1, var2, which var1 is var1, which var2 is var2. How can we understand this? We can do this if we just firstly change the name here as the same name as here. We can be like var2, var3, and var4, right? Now, how to differentiate? We want to store these variables, where these variables inside these variables, isn't it? That we want to store all of the instance variables, the same values that are in var1, var2, basically in the parameters. We want to store the parameters value inside these instance variables, isn't it? Now, to make the program understand that okay, these left sides are instance variables, we use this keyword, this dot var1, this dot var2, this dot var3, this dot var4. Now the program will understand, okay, this dot var1, this is basically object. Okay, which object? This object. This object, okay, this object's var1 will store var1, which is this var1. Got it? This var1. And whenever you don't mention anything, the automatically it will always point to the local variables. So what are the local variables here? In var1, in var2, in var3, in var4. So if you also don't specify this here, this will be the same as this. But if you specify that this dot var1, then it will specify this uh, global context. So it will be like, okay, it will point towards the objects variables. Got it? So this keyword is basically pointing to the object. Got it? So this is nothing but object. Which object? This object. Let's just create an object here. So calculator add calc equals to new calculator add. Okay, can we do this, Tatai? Why is it? Why there is a error here? But didn't I told you that if we don't create a default constructor, the compiler will automatically create a default constructor? Haven't I told you that? Exactly, exactly. We have created one constructor, and the compiler will say, okay, the user has created a constructor. Doesn't matter if it is a default constructor or not, but he has created a constructor. So, I won't be able to create any constructor like this. I will only be able to create constructor like this. So I will always have to have these values inside this. I will always be, yeah, yep, yeah, yeah. So whenever we will be creating this calculator.add, we have to mention it like this. Otherwise, we won't be able to create. So you can ask me that, Dada, why cannot I can is there any way we can also call it the actual way we used to call it? So like the default way we used to call it. So can we do like this? We also can do like this if we specifically mention here our default constructor. So we can be like, okay, calculator add, and we can be like this, and then only we can be like, so if we specifically mention this, we'll be able to do it. Did you understand this? Okay, very good. Now Tatai, I want to make you understand about method overloading. But first of all we need to, yeah, but first of all we need to understand why overloading and why normal methods don't work. Why do we need method overloading basically? So let's just say we have public void add two numbers, right? And we have int a, int b. Sorry, we already have like uh, we already have like two numbers here. Okay, we can do, okay, we don't need actually all of these things. Okay, parameterized constructor and all of these things, we don't need it. We'll just delete it. We'll just need a default constructor. We don't even actually need a default. We don't we don't have we don't actually also need default constructor. So we can be like, okay, let the compiler make one for us. Now if we want to add two numbers, we have to also pass two variables, isn't it? And we'll be like, okay, return a plus b. Can we do this? We can just make it int and we can be like, okay, return a plus b, and let's just run it to understand. Add two numbers, let's just 50 and 80, and just basically wrap it into a system.out.println. Why? Because it is returning us the sum and we are just printing it here. Is it clear? We are just having a method here which is adding two numbers and returning us that a plus b, and we are just receiving it here a plus b, and then after that, after receiving that, we are just printing it. Is it clear? I think it is very simple. Good. Let's just run it and try to understand whether it is working or not. Oh my god, why it is not working? Yeah, it is working. 50 and 80, it is 130. Good. The thing is working fine. Now Tata, I want you to understand, if we want to write it for 3, if we want to write it for 3, don't you think we have to write it again? So obviously we have to write it again. Let's just write it. Add 3 numbers, int a and b, return a plus, add two numbers a b. Now Tata will be like, what? Tata will be like, what is happening here? This is a fancy way to write this thing. I will make you understand what is happening, but this is actually very this is actually very good way of handling things. So first of all, this will be like, first of all, call this whole thing, and whatever the value it will be returning, we'll add c to it. Understand what is happening here. A and b. So we are calling this add two numbers a comma b from here. Okay. Now, hello. Now, hello. Can you hear me? Yeah. Listen. We are just calling this method. What method? This method. We are just calling this method from another method, that is add three numbers. From here we are calling this first method here, add two numbers a comma b, and now first this method will get called, and then a and b will get added and returned from there. And let's say we have called this same method with another one like 90, and we'll just change this to add three numbers, right? 50 and 80, it will be 130, right? So this whole thing will go here, and a and b, a is basically 50, b is 80, this will go here, it will return 130 to this part, so this whole method will get converted into 130, and 130 plus c, that is 90. What is the answer? That is, tell me, 130 plus 220, right? So this lastly 220 will be returned from there and it will be printed. Let's just check whether it is right or wrong. Is it right or wrong? See, right. Now for 4 elements, can we do it? Add 4 numbers, 4 parameters. See, it was easy, and we can call it here and just make it 4 numbers. Just add 100, let's say. Just check whether it is working, right? Now Tata, one thing is sure, that if there are like 100 elements, we have to write 4, 5, 6, 7 up to 100, isn't it? Isn't Shouldn't be there a good way of writing this code? Can we not write same name to everything? Can we not write add, add, add? Can we not do it? Add, add. See, there is no error here. How is it happening? How is it happening, Taday? That is what overloading is. We don't now the user won't remember what the user doesn't have to remember what the particular method is for 59 elements. When he has to add 59 elements, he doesn't have to write add 59 numbers. He doesn't know about it, right? That what is the name of it. So you will be like, okay, add, and he'll send 59 elements from the argument, and 59 elements will get added. That should be the case. But if we don't write it like that way, that will be like very difficult for him to understand that how big of the name the method will have, right? So for that reason, what is method overloading, right? So notice how we can do it. It should be illegal, right? Same name, different methods, same name should be resulting in error, right? Ambiguity. So if there are like same names, we don't know which method will get called. For calc to add 5080, why this method is not called? Why this method is called? Can you take a guess why this method is not called for this method call? Try to guess. Try to guess. I am telling you that this method, right? See it very carefully. This is the method that you have called with 2 elements. I am telling you why this 3 elements has not been called, or why this 4 element has not been called. Which only contains 2 variables. That is right. So the way the compiler don't get confused, because the way method overloading works is overloading. Do you know about overloading? Overloading is basically over specifying something on top of something, right? Basically you are one there is loading and one there is overloading, like doing something more than specified. That is overloading, right? So we should have only one name, but we are having multiple names. How this compiler is not getting confused? So the compiler matches the argument, the parameters, the number of parameters. So if there are different types of parameters with same name, then the compiler will say, okay, there is no problem. So the compiler will be like, okay, there is add functionality that has 2 parameters. Okay, there is another add, but there are 3 parameters. Okay, there is no problem. Okay, there is another add, there is 4 parameters. Okay, there is no problem. Let's say we just copy paste this. Will this be an error? Obviously. Now the compiler will get confused. Even if you write some another logic here, let's just print a b and then return a plus b. This method and this method is different, but still the compiler will get confused because he doesn't know which one to call. This whether he wants to call this or whether he wants to call this. He doesn't know about it. So the only way the method overloading works is to create the methods with same name but different parameters. And also when you want to call a particular method, inside a method overloading thing, you always have to mention the right amount of parameters for the method to get, for the desired method to be called. So for example, if you want to add 4 elements, you have to always pass 4 elements, otherwise you won't be able to run this method. Is it? That is the obvious thing now, because how can you? But array contains, array will be storing some extra space also, right? You don't know how many of the user, like how many numbers the user want to add, right? Let's say you have specified that user won't be needing to add more than 100 variables, right? But the user will tell the program to add 200 numbers, then you cannot do anything because you've already specified 100 numbers, isn't it? So you don't know actually how many uh, variables you need. Also, let's just say the user only needs to add 2 numbers, but you have specified 100 numbers. But we don't need 100 numbers. We don't need the storage of 100 numbers, isn't it? Why do we need to store 100 numbers? You have created an array of 100 numbers. Now 100 numbers, all the numbers will be initialized to 0, right? The space is being wasted or not? If the user wants to add 2 numbers, then 98 of the extra numbers that you have is wasted in the array, isn't it? So that is a downside to use an array. Otherwise, uh, you should always use um, like this if there is any situation here. So you can use uh, add add here with different parameters and it will work. Did you understand the method overloading? This is a simple thing, not very complex. Yeah, good. And similarly, we have constructor overloading. Try to understand what is constructor overloading. We can have multiple constructors. Tell me. We can have multiple constructors, but mult with same name and multiple different parameters. Yes. So here we have that thing. Int I, string n, int I, string n, int a, right? Also, the other tell me a thing. This is a trick question, but let's say we have. Let's see if you are able to tell me. Public void display, right? Int a, int b. This is one. Public void display, int b, int a. Will there be any error in this method overloading thing? Will there be any error? Why? Right. But the names are different. Yeah, the names are. Yeah, but let's say what about this? If we change this into string and this to like string again. No, this is right. The types are different, right? String b and string a. This is right. This is wrong because this is wrong because int b and int a, these are the same types. The type is also same. If the parameters matches, they are compared with the types. So this type, this a's type data type is int, b's data type is int. Again, the names can be different, but the type should be important. Here int is there, here int is there, here int is there, here int is there. This whole thing matches with this one. Then this is not possible. But here there is int, here there is string. So by default only, if this is int, also, it doesn't matter. It doesn't matter. Yeah, because there is another string which in here there is no string. So the number of total int here is 2. Number of total int here is 1. There is a difference, and that because of that difference, this is valid method overloading. This is not valid method overloading. Did you get this? Good, very good. Did you understand this? Good. Okay. There is a last type of constructor, that is copy constructor. We will study about it. What is copy constructor? Let's say we create a calculator dot add. Let's just not create anything here. Let's just make part 3 here. Day 5 part 3, or just name it. Okay, just day 5 construct, or just part 3. Part 3.java. So many parts. PSBM. Now just add class animals, right? And first of all, we'll create because we have an class with animals name, we can make a book class in this particular package we have, like in different programs. Okay, class we have book. Let's say int book name. So int name, int, how can it be int name? String name, int pages, right? And we'll create this int name, and again string name and int pages, and it will be like this name equals to name, this pages equals to pages. Is it clear? This is clear, right? This is parameterized constructor. What is copy constructor here? That is what I am trying to make you understand, Rohan. Okay, wait a minute. Yeah. So what is copy constructor? So let's say we create a book here. Book equals to new book, and let's just name the book as the complete reference, and there is pages like 580. Okay, and is it okay? Yeah, we have created this we have created this parameters constructor, and we have created this. Now what I want to do is, like, I want to just copy the pages from this to another one. Got it? Like, I want to create book 2 equals to book dot name, right? Got it? But we cannot do that, right? Because book 2 is the whole object, and book dot name is particularly this string, and this is like the whole reference, right? This isn't right, isn't it? Okay, just not created yet. We'll create it. We'll make it I'll make you understand. Wait a minute. I have some work. I'll just come in 5 minutes. Okay. What is the time right now? 5:24. It's okay. You don't have anything to do, right? Yeah, just wait for 5 minutes. This is very interesting. I will tell you. Goodbye. Goodbye. Okay, just wait for 5 minutes. I'll come. Hello, can you hear me, Tatai? Yeah. So did you get the yeah? Did you get the constructor thing? Hello, hello. Yeah, can you hear me? Yes, yes, yes. I can. So what is the copy constructor, right? So, uh, sorry for the delay. Yeah, copy const. Yes, what is copy constructor? So let's say we have another book here. So, another book here, book two equals to new book. We don't actually need new book. Oh, we need it. Sorry. Yeah. Now, what happens is this copy constructor will take another book object here, and yes, and we will, yeah, I'll tell you. Wait, and we will basically have this name. So this dot name equals to object dot name, this dot pages equals to object dot pages, and we'll just pass book. Yeah. So basically, this copy constructor is basically used to copy one object to another. Did you understand? So what happens is, so this copy constructor, so this copy constructor is used to copy one object to another. But this is not exactly what I explained you the first time. So at the first time I explained you that whenever there will be non-primitive data types and you do object equals to object 2, the reference is copied, right? But in here the value is copied. See, we have we have just copied the values. Now if we do here, now if we have, now if we try to do here that book name or pages equals to 700, do you think it will be changed in book 2? Exactly, it will not change because you have just copied the values and not references. See, I have just object dot name. Object dot name is basically string, so I've just copied the name here. Object dot pages is int. I've just copied that pages here. But whenever you write object equals to object 2, the reference is copied and not the values. So if you change object 1, the object 2 will also change. Got it? But in here, the copy constructor is basically used to copy one object to another. Yes, like one object's attributes to another. Got it? So that changing one object doesn't actually change another object, right? Did you got it? Goodbye. Why? Now, today it's already 6. How can you visit me? This will class will go on till 6:30 or 6:45. Okay. Okay. You can just come here and your father. Okay, we'll just uh, talk about it later because this is recorded, right? So Java static keyword. I've already told about Java static keyword. Yeah, I don't need to hmm, hmm, right, right, very good. Right. So, so, hmm, right, right, exactly. Yes. Yep, yep. So, watch a thing. So, there is this heap memory. There has been static variables like id equals to 222, name equals to Aryan, and id equals to 111, name equals to Karan. And this college equals, yeah, like static variables are also stored here, and oh sorry, this is not static variable. This is like normal instance variables, right? Yeah. So these are the instance variable, int roll number and string name, right? And the college ITS, it is static variable that is stored here. And see how college ITS is shared among all the uh, object. So this id equals to 222 is another object, id equals to 111 is another object, and the both of the things are shared by these objects, right? This both of the things share the same college equals to ITS, right? So what are the restriction of the static method? The static method cannot use non-static data members or not or call a non-static method directly. Did you got it? So that is the bad thing about it, that whenever you use a static method, it by creating a class, creating an object, the main method, the public static void main method is a static method, and whenever you try to try to call another method that is non-static, you just call by creating an object first, and you then you call that, isn't it? So let's say yeah, scanner class. So let's say simple thing I want to make you understand. Let's say this public void display is there, right? This is non-static method, right? And if you want to call it inside this public static void method, you have to create a box class first, a box object first, that I have created, and then I have called this box one dot display. So this is the indirect way to call this non-static method from static method. See, this is the question: why is the Java main method static? In Java, the main method is static because the object is not required to call a static method. If it were a non-static method, the JVM would create an object first and then call the main method, which would lead to the problem of extra memory allocation. Got it? So if we don't make the Java static, the main method static, then yeah, I'm just explaining that if you the main did you understand the question first? Why the Java main method? Yeah. So in Java, listen. Yes, the main method. Whenever you try to call the main method, if it is not static, if it is normal method, you have to create an object first, isn't it? You have to create an object first, and then you have to call that method of the main class. So like you have this class like day 5. Nice. So if you want to call, if you don't make this static, you have to create day 5's object, and then day 5's object name dot main will create this, will help this class to call this much method, isn't it? But that is not how JVM will call this method. JVM will basically call this method by day 5 dot main, because this is static method, isn't it? This is the way how JVM will call this method. Did you got it? Because this is static method, and static method are accessed by the class name. The class name dot main, this will call this, and this will basically lead to the say this will basically lead to the saving of storage, because you are not creating another object here, you are just calling by the class name. So you don't need to call the class, you don't need to create objects here. So now by not creating object, you save some space. That is what it is told here. Exactly. And you don't have to create objects to it, right? Okay. Okay, but next it is said Java static block. What is Java static block? It is used to initialize the static data member. Yes, it is executed before the main method at the time of class loading. Yes, so let's just say we have a static method here. We have some we have some calculation here, but before that we just make it static and then start writing program, and we just print some value that the book let's just have some, all the books are uh, redistributed distributed, right? And let's have some notifications here, right? uh, Please give back the books, please return the books, return the books that you guys, that uh, you people have taken during August month, right? Now let's see what happens. Wait a minute. Oh, sorry, I have not created any public static void main here. This will be here. So before the public static void main here, it will run. Got it? So before this static method, that will run. Something is happening here. For some reason it is not working. I'll have to see. It should work. I think there's some issue with the compiler. Yeah, whatever it is, that is not so important. We rarely use static method. Okay. Uh, let's just read about it. So in this case, the static block contains which prints the additional. Therefore, blue.js shit. The static block is executed first, printing the message for the static block, followed by the execution of the main method printing element. Okay, sir. There is some error. Okay, so listen. Let's just do it. Okay, do you know that there is a call like this, that whenever you call system dot exit dot 0, the compiler will stop executing the program at this line. So let's say the compiler creates two object here, and whenever it reaches here, without even without even assigning this book pages equal to 700 and printing this line, it will always return. See that book dot something happened again. So there is this compiler issue, I think, whatever it is. Uh, yeah, but it just returns basically. It just it just hints the compiler to stop executing. System.exit.0. Break basically system.exit will shut down the whole program, and break will just break the loop. The rest will continue. Okay, what is static nested class? A static nested class is declared within the static method, right? It behaves like a regular, yes. So we have a class A and there is a class static class B. Okay, so it behaves like a regular top level class but is nested for packaging convenience. Static nested classes cannot directly access non-static members of the enclosing classes. This is very important. We'll learn about the nested class later. Advantages of static keyword. Same memory. Instead of each object having its own copy of a variable, static variables are shared across, you know it. Faster access, utility methods, good for constants. Yeah, it's good for constant. Like whatever the value is, if it doesn't change, we can make it static, right? Keep codes like pi, yes, the gravitation value 9.8. So yes, oh right. Yep. So like the pi also. So if we also make it public static final, right? Final is like constant, you cannot change it. So public static final pi equals to 3.14159, isn't it? Yeah, it is the final value, and it is also static because every classes can use particular that value. Every classes can use that particular value. Runs automatically when the class loads. Reduce object dependency. All of the things. Reduce object dependency means you don't need object to run that particular variable or access that particular variable. What is this? This keyword. This keyword always point to the object, isn't it? Objects variable. This keyword uh, points to the object, and object instant variables equals to object variables, isn't it? The object, the whole object. This only this will point to the whole object, and after that whole object you specify what do you want to. Yes. So this, what is this? This is basically pointing to the whole object, and you are specifying this dot name. So you are specifying that on the whole object, in the whole object there is a specific variable called name. You put that variable, uh, you assign some value inside that variable name. Again you have written the same thing, that these pages, this dot pages equals to assign a particular value in the pages. Did you understand this? Good boy. Represent the current object. Think of this as a way for an object to refer to itself. It is an object, it's calling a method. If an object is calling a method, this points to that specific instance. Got it? Helps avoid confusion. That I have just told you that you can name this as same thing, and this will not create a confusion between you between. Yes, exactly. Calls other methods in the same class. We don't always need this, but we can use it explicitly to call another method within the same class. We'll talk about it later. There is some use cases to this. Supports constructor chaining. This can be used inside a constructor to call another constructor in the same class, helping reuse code. We can also call constructor in it. Like we can also do like this dot, I think book. Oh, sorry, sorry, sorry. I think this is like uh I have to see this. I'll have to see the code. Yeah, this we can also do like this at a particular time so that we can call this. Alright, yep. This will go to the infinite. This will go into an infinite loop. Yeah, recursive constructor call. But we can do this. This is valid. Okay, this is basically valid. We can basically copy this or write some more code, and we can be like this, and this will basically call that. Okay, pass the current object as an argument. Sometimes we need to send the current object to another method or class. This makes that possible. Returns the current object. A method can return this, allowing method chaining, which is common in Fluent APIs. We'll study about it later. Okay. There is some example to this. This is not important. Okay, so we'll just watch the this keyword. Okay, they have written this program that I see. There is class A, and there is a default constructor that is printing system.out.println hello A, and they have created another parameterized constructor. Inside it, they have called this with without any parameter. So basically, they are calling this default constructor from here. So first of all, they have created this parameterized constructor with this. They have created this object with parameterized constructor. So this will get called, and whenever this will get called, this system dot out dot print, this will also get called. So basically, from one constructor they are calling another constructor. Is it clear? It's simple. Just you can also call the default constructor first, and from the default constructor you can also call the parameterized constructor from there. The same thing. We can also pass this as the object reference. Got it? So yes, so let's say we were doing something like book here, like, isn't it? We were we were doing something book here. We can also be like we from here, if this will point to this object, we can also pass this uh, to another any object. So let's say there is some method, uh, there is some method public void another method, and it is doing something, and at the last it is just calling another method. Got it? Like calling a different method. Let's say copy method, which will pass this, and this copy method will basically, what it will do is like, this will receive a book object, isn't it, and copy it. Hello? Yeah, can you hear me? Yeah. Yes, yes, I can hear you. So yeah. So what I was telling is that let's say there is another method here, and also there is a copy method from here, and we are calling copy method from this another method, and we are passing this as the reference, and this will receive book object, because obviously this is basically pointing to this whole object, and this will receive the book object here and will just copy it. Got it? So this is also a use case of this, but this is not very common. Got it? We'll just prefer this way, because we are just copying this, right? We will just make a copy constructor to do this, but there might be some usage there. Got it? Yeah, I'm telling you that we can also pass this keyword as a we can also pass this keyword as a parameter. Got it? So yeah, so like this. So we are passing this keyword as parameter here, argument here, and this is the parameter that is receiving that this keyword. Because what is this? This is basically pointing to the whole object. And what is the whole object? The book object, book obj. So that book obj will contain name, pages. Got it? So this will basically point to this whole thing, and this will basically point to another thing. Got it? This doesn't make any sense, but I have just written this because we can also do this. We can also write programs, because 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 it is we can do this. There can be some use cases where we use this we can just return this, or we can just do something with this. Okay. Yeah. Current class instance, this is also, so we can also use this keyword to return the current class instance, but that is not needed, because already we are storing that inside the book. Why do we need to create another one, right? But we can do that. If you want like any other method, like a special method, uh, a method that returns object, like public book return obj, right? And it will like return this. So what does this object return object does? It basically returns its own object. Got it? So what it will do is like uh, it will like first of all create new obj, new book, and it will be like, okay, return obj. Got it? And it will return this whole object into this new book. Did you understand this? This is method, right? This is another method that I just make. Book is this method that is returning the same this book only to this new book. So new book and book will contain the same thing. The references will be the same. So we can also check here if book equals to new book, same objects. Why is it not working? Yeah, got it. Also, I think the static method should work right now. Static. the please return all the books. Let's just check whether it is working or not. Yeah, see, it is working. Got it? Yeah, this keyword is also easy, right? Okay, after that, what is left? Okay, let's just do inheritance. Inheritance. Okay. So before inheritance, we have to understand what is parent class and what is child class. Got it? Yes. Yep. Yep, I can hear you. Hello. Yep, yep. Yep. So let's just first talk about what is like parent class and what is like child class. Super class, subclass. Yeah. I'll just talk about it one more time. So let's say if this is parent class, if this is parent class, this is a child class. This is a child class, right? So whatever variables this class child class will have, let's say child, let's say child name, child child age, and things like that. Whatever it will contain, the parent will also contain it. Sorry. Yes, this is basically the parent one. Sorry, I've just made it wrong. গিটারটা রাখ তাতাই focus on one thing, otherwise tell me, I'll leave. Okay, so this is the parent class, right? And whatever the parent will contain, the child will also contain the same thing. Okay, but not the vice versa thing. So if you talk about the child thing, here the child will also contain the child name, but the parent will not know about it. Got it? So the parent will basically not know about it. What is the what child what are the extra things that child has? Child may have more things. Like child may have extra things like child, let's say child, what do you call it? Yeah, number. Yeah, child role, let's say. That parent doesn't have, but child has it. But parent will not know about it. Now, to have this exact same feature inside a program, we need to code it. How can we code it? We can basically create day 5 part 4 .java and like be like psbm, and let's just name the class as class uh, parent, let's say, and have int name, sorry, string name, int age, right? Now we create class child, right? And it has the same property as string name and int age and extra functionality, that is role, isn't it? But this class, but do you think these two classes are connected? No. How can we connect them? By using extends keyword. Extends keywords. This is the keyword. Extends keywords. So now we have to give the name of the parent. So in our case, it is just parent. So I've created it. Now we don't need to create again the same variables. The child will contain these two variables by its own. Do you understand this? Did you understand this part? This child doesn't need to create, this child doesn't need to have again the same two variables. It will by default, whenever you have written extends, it will by default inherit the name and age inside this child class. Did you understand? Now how to write this program nicely? How can we do that? Let's say we have, let's say first we create constructor, right? So let's just have this done. Let's just create this. And how can we do that? We can basically, this name equals to name, simple thing, right? This age equals to age. And now 1 minute, I'll tell you what is happening here. First of all, let's create a parent class, a parent object. So let's just give it an, why here? This is just day 5 part 4 now. This is your main class. All of the objects you will create will always be inside it now. I've told you this is how you write program. So first of all, you give the parent name. So let's say I will give my parent name, and let's say in age we give 60, right? Just a random number. Okay. So this is done. This is working. It is working, right? Now what about child? We have to make the child constructor, isn't it? So let's create child constructor. And how many values should we take? Why single? There are 3 variables, right? String name, int age and int role. Why? Because we have extend the parent, and some of the properties that parent had will also get inherited by this child. So by default, name and age will also come here. So first of all, we'll create int age, sorry, string name, int age and int role, isn't it? Now the thing is how to call this particular thing, isn't it? You have to call this parent from this constructor to be able to store this name equals to name, this age equals to age, isn't it? How can we do that? No, we use the super keyword. What keyword? Super keyword. Super is super. Basically, super is. Why do we use super? It is just basically the parent class is also known as super class, and the child class is known as subclass. Subclass. Yes. The super. What will the super do? Super will basically call the parents constructor. Call the parents constructor. Now we will have to give the name and age here, because we have written name and age here. So name, let's name and age. Let's give the name and age here. And always remember the super keyword. The super keyword should be the first call. Super keyword should be the first line after you have started the constructor. If you write something here, if you write something here, it will give error. See, call to super must be first statement in constructor body. Got it? So this is the first statement. This should be the first statement. Now we have already stored the name and age here. What do we need to store? Refer multiple classes. Yep, yep. We'll also see about it. Don't worry. First of all, let's understand the inheritance, how inheritance work. Yes, so super name and age is there, and now we have already stored the name and age for the child class. How can we store the last option? This dot role equals to role, isn't it? Now all of the things are done. We just need to use void display. Let's just check. Let's just create a child here. And also I have to give my roll number. Let's give it 99, and let's check whether it is running fine. Got it? Now Tatai, let's try to understand. If there is a method here, uh, let's say if there is a method here like public void, yeah, let's say if there is a method here public void display, and we try to print here. Can you see it? Can you see it now? Hello? Can you see it now? Rejoin. This is the okay. So let's say this parent class has display method, right? This parent class has this display method which contains this is the parents class, right? Now if we try to, so there are two display method here, there is one display method and here there is the display method. So let's just change the name, display parent. Let's just change the name here, display parent. Now see, there are two. There are one display parent here. Now, how can we call display parent from here? From here, how can we call display parent from here? From the child class. Can we do that? Yes, exactly. So you can be like super dot display parent, and the parent will call. Parent will get call. See, this is the parent class. So basically, did you understand what is happening here? The this keyword, the this keyword refers to this whole object, and the super keyword refers to the parent object. Got it? Yes. Because because this is the whole object, and you have to also mention the method's name. Otherwise, how can you understand that what is that? Isn't it? Because this is the constructor. We can also do. We can. We were also doing this. We were also doing this, na, like this, and we were also doing name, age, role. We can also do this. Like we can also have another constructor and call that constructor from here. That is the same thing. Got it? So the constructor can be called using this and super using that first bracket. Got it? This is the inheritance part that you have completed. I think uh, we should. That is it for today. We have too many things. You won't be able to process much after this because there are like a lot of things, and I cannot make you understand all of the things by today itself. There are like too many things. I'll have to divide some classes uh, through this week so that we can complete most of the stuff. But yeah, did you understand all of the things that I did today? Yeah, good. Yeah, good. So I think that is done for today. I'll just push it to the GitHub so that you can understand. CMD git status git add git commit added day 4 and 5 git push origin main. Yep, yep. Yeah, I'll upload it. Don't worry. Okay, we have uploaded it. Uh, where is that? Where is Java? Yeah, Java A to Z. This is here. Yeah, it is available here. Okay, we'll just leave for today. I will also upload this. Uh, how can I share it? Uh, should I share the link? Okay, I'll share it. Oh, okay, do one thing. I will share this into my chat. You just share it to the group. Oops. Yeah, I've sent it here. Okay, bye.